Today we're going to talk about solving two-step equations. Now this is the exact same as one-step equations, except now we just do two steps. So step number one, we're going to use the inverse operation. So that's still the same, we always use the inverse operation, to remove the constant and apply that to both sides of the equation. So if we look at letter E here, we are trying to isolate our variable, and that's a part of the term 2x. So what I need to do is try and get 2x by itself. The way I'm going to do that is by moving this constant. So remember, a constant is a number without a variable. And we're going to use our inverse operation. So instead of adding 10, we are going to subtract 10 on both sides. So then when we subtract, plus 10 minus 10 cancels out to 0, so we're left with 2x equals, and now we have 15 minus 10, which is 5. Well, now this should look really familiar to what we did last class. So the same rules apply. Step number 2, we use the inverse operation to remove the, now this 2 right here, there's a vocab word for it. It's not a constant, because remember, a constant doesn't have a variable with it. This one, which we talked about last class, is the coefficient. The coefficient. So the coefficient is the number in front of the variable, or the number that's being multiplied by the variable. So now what we're going to do is the inverse operation. Well, right here is multiplication, so that means we need to do division on both sides. And we need to get x by itself, so we are going to divide both sides by 2. And when we do that, 2 divided by 2 is 1x, or x. And then we have 5 over 2. Now 5 over 2 doesn't simplify, but we could write this as 2.5 or 2 1/2. Any one of these three answers would be correct. For the sake of this, I'm just going to leave it as an improper fraction. So we'll leave it as 5 over 2. And then step number 3, we always want to make sure we write our answer as an equation. And so we talked about this last time. We could use the number 1 to represent a. So this is like x equals 1 or 1 equals x. All that is saying is it doesn't matter which side of the equation the variable is on, it would still be fine. So most people prefer to see it this first way, where the variable is on the left-hand side of the equals versus it being on the right-hand side. But both are correct. All right, let's do a few more examples here. So step number 1, we remove the constant, because remember, we're trying to isolate this term, so we're trying to isolate 5x. So we're going to remove the constant using our inverse operation, so we need to add 1.2 on both sides. Now be really careful, we need to make sure that we line up our decimal point on this side. Well, now we have 5x equals, and then 28.8 plus 1.2 is 30.0, which is just 30. And then now we need to remove the coefficient. We need to remove this 5, so the inverse operation of multiplication is division. So we're going to divide both sides by 5. Now we have x equals 30 divided by 5, which is 6. So x equals 6. All right, our next one, we're trying to isolate x over 10, so we need to subtract that constant, so minus 3.1 on both sides. So we're left with x over 10 equals 5.2 minus 3.1 is 2.1. Now we solve for x. The inverse operation of division is multiplication, so we're going to multiply by 10. And this is like 10 over 1. So now we can see that those 10s cancel, and we are left with x equals, well, 2.1 times 10 is 21, because we can use the trick of moving it over one decimal place since we're multiplying by 10. So therefore, our final answer, x equals 21. Letter H, we are isolating the term of 3/4 x. So that means we need to move our constant. So the inverse operation of subtraction is addition. So we're going to add 6 on both sides. So then we are left with 3/4 x equals, well, 3 plus 6 is 9. We need to isolate x. Now let's think back. Right here we're multiplying, so technically we would divide by 3/4. Well, if we had 3/4 divided by 3/4, if we divide with two fractions, we have to keep change, so that would be 3/4 times the reciprocal of 4/3, and then we could see that cancels because we end up having 12/12, which is 1. So what we're going to do is we're going to take, knowing this fact right here, and we're going to go straight to that second step. So we're going to multiply both sides by the reciprocal. Because remember, we're trying to get x by itself, and we want it to be a single 1x. So now we can see those 4's cancel and those 3's cancel because of it being 12/12. So now we have x equals, and then we can put 9/1. So then we have 9 times 4, which is 36, and then 1 times 3, which is 3, and then 36/3 simplifies to 12. So x equals 12. All right, depending on how you're feeling here, if you're feeling good, I want you to go ahead and try these 6 example problems underneath, and then come back and check your answers. If you still want a little bit more practice, then you can continue to watch in this video, and then whenever you're feeling good, try a few on your own, and then come back and check. All right, so this one here, we are isolating 2m, so that means we need to subtract 5 on both sides of our equation. So now we have 2m equals, and 17 minus 5 is 12. Then we need to use our inverse operation, so we're going to divide both sides by 2. So then we have m equals 6. Our next one, we need to isolate -5n. So we're going to add 1 on both sides. So we have -5n equals, and then 19 plus 1 is 20. Now this one here, think about the operation that's happening between this -5 and n. That's multiplication. So the inverse operation of multiplication is division. So we are going to divide both sides not by just 5, but a -5. We're going to take the negative with it because in the end we want a positive variable here. So -5 divided by a -1, that ends up canceling to be a +1. So we have +1n, or n, which is then equal to 20 divided by -5, which is -4. All right, our next one. This is the variable o, not a 0, so we're isolating o/2. So that means we need to subtract 3.4 on both sides. So we're left with o/2 equals 12.4 minus 3.4 is 9. Inverse operation of division is multiplication, so we're going to multiply both sides by 2. This is like 2/1. So we see those 2's cancel, so we're left with o equals, and then 9 times 2 is 18. All right, number 16, we need to isolate this term of -p/8. So we're going to subtract 2 on both sides. So we're left with -p/8, and then equals 5 minus 2, which is 3. Now here, notice that the whole term is negative. So what we're going to do is we're going to multiply by a -8, or -8/1, on both sides. The reason we're doing that is because a negative times a negative gives us a positive p, and that's what we want. So those 8s, we can see they cancel. So we have a positive p equals, and then 3 times -8 is -24. So p equals -24. Number 17, isolate 3/4 q. So we need to add 7 on both sides of our equation. So we're left with 3/4 q, and then equals 14 plus 7 is 21. Now remember, we need to isolate Q here. This is like letter H right up above, and we could go straight to that step of multiplying by the reciprocal so that it all cancels out to 1. So that's what we're going to do here. So the reciprocal of 3/4 is 4/3. So we multiply by 4/3 on both sides. So we see those 4's cancel, those 3's cancel. That's what we wanted. So we have 1Q, and then equals, we can put 21 over 1. So now we have 21 times 4, which is 84, and then 1 times 3, which is 3. And then 3 can go into 84 28 times. So Q equals 28. And then last but not least on this side, we are isolating our negative 1/2 R. So that means we need to add 1/3 on both sides. So we're left with negative 1/2 R equals 2/3 plus 1/3 is 3/3 or 1 whole. So it equals 1. Now, same thing like what we just did on number 17. We want to get this fraction away. We want to isolate R, so we need to multiply by the reciprocal. Well, the reciprocal of 1/2 would be 2 over 1. And we're going to specifically bring the negative, because remember, if we multiply two negatives, then we get a positive, and that's what we want. So we multiply this side by negative 2 over 1, which is just negative 2. So now we can see that those negative 2's cancel out. So we have R equals, and then 1 times negative 2 is negative 2.